That's very helpful. Let's go to the next one, which is deep learning. Tell us about that.
So deep learning is like a subset of machine learning, which uses something called neural networks behind the scenes. And the intuition is that it mimics the way humans have connectors in our brains to make decisions. So that's the whole thinking behind neural networks.
Okay.
So it's mimicking how we humans make decisions.
Hmm.
And the way machine learning differs from deep learning is that deep learning can find which combination of attributes can learn a specific prediction. It learns the weights automatically. It learns which attributes to use. Whereas for machine learning, you need to say use maybe attribute X, Y, and Z to make predictions.
Is deep learning like is like autonomous vehicles like a form of deep learning, because it's not only using data that might be in a system, but also all sorts of data all around a vehicle to make decisions as to which way to move the vehicle.
There are different uses of deep learning within a self-driving car. So in order to see obstacles and objects on the road, it uses computer vision paired with deep learning to make those decisions.
Got it. And you know, it's we'll get into this also a little bit later in the conversation, I hope. But you know, all of this machine learning and particularly deep learning, I mean, my understanding is that it takes a lot of hardware, a lot of processing, right? I mean, what I listened to this great interview. Is you must know Lex Friedman, right? Who does a great podcast, and and he's an AI, and he interviewed Elon Musk like about a year ago, and you know, even Elon Musk was saying how challenging it was to get Tesla to do its autonomous, you know, with its autonomous vehicles, because he said it's a combination of machine learning and deep learning, but the processors that are needed, the hardware, you know, to put into a car to make a split-second decision not to run over a puppy, you know, he said it's really hard.
It's really hard, yes, and because these deep learning networks are so complex, they can sometimes take time to make predictions. It's not instantaneous. So there's a trade-off between making a prediction fast enough versus making an accurate prediction. And that's hard in a self-driving car, because these things need to be embedded within the vehicle itself.
I think about that as well, like Kavita, like I was just about this the other day. I was walking through an airport, and I was walking through like a terminal, and there's masses of people walking towards me, you know. And I just happened to bump into a friend there, and I was thinking to myself like afterwards how like there's just thousands of people coming by me, and my brain is able to like instantaneously determine that like don't know this person, don't know this person, don't know this person, don't know this person. I know this person. Do you know what I mean?
Yeah.
And I think about like the power of like the human brain, like that can perform those levels of processing and functioning. And what would be needed for a computer to do the same thing just seems like just a huge challenge, you know?
Yeah, it is an uphill battle, and we are trying to make AI more and more like humans, but we're not quite there yet, especially when it comes to like common sense reasoning. We're just not there yet. It's still memorizing based on data and weights. So the common sense reasoning component is still being worked on.